An activation function is a mathematical function used in artificial neural networks to introduce nonlinearity into the model. It determines the output of a neuron given its input. There are several activation functions used in deep learning, but I will explain two popular ones along with their real-time examples and the companies developing them. Rectified linear unit, ReLU. ReLU is one of the most commonly used activation functions. It returns the input directly if it is positive and zero otherwise. Mathematically, it can be represented as f x equals max 0 x. ReLU is efficient to compute and helps in mitigating the vanishing gradient problem. It is often used in hidden layers of deep neural networks. Real-time example. Let's say you have a neural network for image classification. Each neuron in the hidden layers can use the ReLU activation function. When an image is fed into the network, ReLU helps in determining which features are present, positive values, and which are not, zero values, aiding the network's decision-making process. Companies developing ReLU-based models. ReLU is a widely used activation function, and many companies and research organizations develop models that employ ReLU. Some notable examples include Google Brain, Facebook AI Research, OpenAI, and DeepMind. Sigmoid function. The sigmoid function is a smooth, S-shaped curve that maps any real-valued number to a value between 0 and 1. It is expressed as f x equals 1/1 plus e carat x. Sigmoid functions are commonly used in binary classification tasks as they squash the input into a probability range. They are differentiable and have well-defined derivatives, making them suitable for backpropagation. Real-time example. Consider an email spam classification system. After training a neural network with a sigmoid activation function, you can feed an email as input. The sigmoid activation function can output a probability value between 0 and 1, indicating the likelihood of the email being spam, closer to 1, or not, closer to 0. Companies developing sigmoid-based models. Sigmoid activation functions have been extensively used in the past, and many companies have developed models incorporating them. Some prominent companies in the field of machine learning and deep learning, such as Google, Facebook, Microsoft, and IBM, have developed models with sigmoid activation functions. It's important to note that activation functions are not tied to specific companies but rather used by researchers, developers, and engineers across various organizations to build neural networks and deep learning models. Different activation functions serve different purposes, and their usage depends on the specific task and requirements of the model being developed. Activation functions are primarily used in the field of deep learning and artificial neural networks, which are computational models inspired by the human brain. These models are implemented using software development frameworks and libraries that provide tools and functions for building and training neural networks. Some commonly used software development technologies and frameworks for developing deep learning models include TensorFlow. TensorFlow is an open-source deep learning framework developed by Google. It provides a comprehensive ecosystem of tools, libraries, and resources for building and training neural networks. TensorFlow supports various activation functions, including ReLU, Sigmoid, TAN, and more. It allows developers to define and customize activation functions as per their requirements. PyTorch. PyTorch is another popular open-source deep learning framework that provides dynamic neural network capabilities. Developed by Facebook's AI Research Lab, PyTorch offers a flexible and intuitive interface for building deep learning models. It supports a wide range of activation functions and allows developers to define custom activation functions using Python. Keras. Keras is a high-level neural networks API written in Python. It is built on top of TensorFlow and provides a user-friendly and easy-to-use interface for designing deep learning models. Keras supports various activation functions, and developers can easily specify the desired activation function for each layer of the neural network. Caffe is a deep learning framework developed by Berkeley AI Research, BEAR. It is known for its efficiency and speed, particularly in computer vision tasks. Caffe supports different activation functions, including ReLU, Sigmoid, TAN, and more, which can be specified while designing the network architecture. MXNet is an open-source deep learning framework that offers flexible and efficient tools for building and training neural networks. MXNet supports a wide range of activation functions and provides options for customization. It is designed to scale and can be used on various platforms, including CPUs, GPUs, and distributed systems. These are just a few examples of software development technologies and frameworks used for developing deep learning models that incorporate activation functions. The choice of technology depends on factors such as the specific requirements of the project, the programming language preference, and the availability of resources and support.